The CNC150 heavy-duty bending machine is used to fabricate tubes and pipes which are placed into boilers which create energy that's used throughout the world.
This particular machine is programmed to do actually 130 bends. Completely variable, can be set up for every different pipe size they bend.
Each part is going to be identical to the part before and after.
I am from third largest boiler making company in this world. We are doubling our capacity. We are buying a lot of machines, and by evaluation process we have found out Pines is the best, and we have ordered 10 machines on them.
In the boiler industry, they generally create small bends and then weld them together on site. There's a high risk that any one of those welds, after they're completed and deeply buried in the boiler, will leak. The people that build boilers would very much like to avoid welding altogether. And so what they decided to do was to weld long pieces of pipe together. The bending machine now has to deal with very long pieces of pipe.
On a regular CNC150, we'd be able to handle tubes up to about 4 meters in length. On this machine, we can handle tubes up to 20 meters in length with a much heavier wall than we would normally have on a CNC150. So we're handling a lot more mass of tube in length and in weight.
The loader arms will move into an upward position. They'll pick off a piece of tube which will roll along the yellow arms that you see here. They'll come to a stop at the end. The tube supports will move into position to accept the tube that's coming off the loader arms, and with powered in-feed rollers, we'll feed them into the carriage assembly. It will come into position in this area here and come in contact with the laser beam, and it sends a signal back to the control station to know where the front of the tube is. The carriage at that time will feed it in forward into the clamp die section here of the bend die. The clamp die will close, the carriage will open up and back out of the way for its next Y-axis move. The pressure die assembly will come into contact with the bend die, and the booster assembly will close. And the bending sequence will begin when the swing arm begins to form the part about the bend die. At the end of the bend cycle, the split die will split apart, which will allow the carriage to more easily feed the tube off of the bend die and reposition it for the next bend.
Basically, we can control the angle of the bend and the distance between bends, and also the rotation of bend. Because of the long lengths of pipe, has to be able to rotate parts that are 30 feet long. This requires a lot of torque and a lot of strength.
So we definitely had to beef up the carriage both along its feed axis and its rotational axis to be able to handle those extreme loads over time. Extra hands are needed usually to help unload the part, because we're talking about parts that may be 20 meters long and weigh in excess of 1,000 pounds.
The machine is equipped with a laser barrier system. You can create different exclusion zones where if anybody walks within that exclusion zone, the machine will automatically shut off.
One of the cost-saving and time-saving technologies we introduced in the CNC150 is the automatic tool positioning and pressure setting devices, which is located down in this section here. There's an Acme screw that has feedback with the control system, and it allows an operator, when changing over to part, to select a tube size, basically hit load, and the tools will move automatically into position. You could minimize a tool changeover from 45 minutes down to 15 minutes, let's say.
It actually boosts the pipe, which means it pushes on the end of the pipe while it's bending, which reduces the tension in the outside radius and therefore minimizes the wall thinning. And we've been able to actually program the pressure settings for the machine. So once a bending program is downloaded into it, the pressures which are required to make the bend are automatically built into that program. This is going a long way away from the United States, and so we have to be particularly confident that when it's there, we will be able to support it. Yeah, not only are we building the machine here and fully testing it by making the customers parts here, having them come and verify that the parts are good, and then we'll send our technicians over there, assemble the machine, test it, and do more trials in their facility.
After that, we'll start with operator training and start producing the customer's parts within about 2 days after the machine has been assembled. Once the machine is up and running and the customer is running it, we'll start with maintenance and programmer training so they have a thorough understanding of the control.
A friend of mine who's a maintenance manager has always told us to believe in a maintenance-free concept. So a lot of things went into the design of this equipment to decrease the amount of maintenance required. So there's a lot of visual indicators and feedback with the control to say when something should be done.
We can install a camera, which is accessed through the internet, and we can view the machine in our factory. And if there are any malfunctions with the machine, we can actually see them, and we can monitor the control on the machine at the same time. We can reprogram it if necessary, or we can guide the customer as to how they can put right any faults that we might see there. The customer wanted an 18-month warranty on this machine. We actually offered them a 3-year warranty. One of the things that people buy Pines machines for is our experience. Pines has been building pipe bending equipment since 1943. And obviously during that time there's a lot of experience been gathered, a lot of records been made, a lot of information created. All of that experience was built into this machine.
I am really happy with this machine. It is made to more than my expectation. It is going to be a big asset for our company. We have a lot of confidence in this Pines group, and probably if another requirement is there, definitely we will come back to Pines.